All right, ladies and gentlemen, this is going to be a really difficult video to make. It's a lot of things to point out, and so I don't know how this is going to go. I've just kind of prepared a couple things here, and I'm going to see if I can make some sense of this in a way that kind of holds itself together and might have some value to you. I want to start out something that's been a hot topic, and I've seen it for the past week in the news. It has to do with supervolcanoes, in particular Yellowstone in the United States. And that's a very real issue, and scientists are really scratching their head, and there's a lot of ambiguity around, is it a real threat? You know, it could happen tomorrow, it could happen in 50,000 years. And anytime you see a range like that, you need to consider that they may be just trying to keep us all feeling, safe, because supervolcanoes are very scary, and I don't blame them for that, and I don't think it's a conspiracy theory that they're trying to pull over our eyes. I just think if you don't know something, why would you, incite panic? And so on that note, I'm not creating this video to make anybody panic, but the world's a dangerous place, and we all live in it. And so it's good to understand what's actually out there. And so I'm going to start with this screen. We're going to talk about supervolcanoes. I'm probably going to jump into a little bit of earthquakes because and how they relate to volcanoes specifically, and then a little bit on hydrothermal vents. I've gotten some questions on hydrothermal vents, and I think that people don't understand exactly what that means. So I'll show you what that is. Now, my goal, my ultimate personal goal at the end of this video is that hopefully someone, maybe multiple people watching this video, will start to scratch your head and wonder if it's possible that, as I've said before in previous videos, the Earth is warming from the earth to the water to the air instead of CO2, heating the other way around. It's a lot easier for something of more mass to heat something of less mass, like water to air, than it is to go the other way around. So just some food for thought. Let's get into this. This here, what we're looking at, is a map I created because I couldn't find anything that could be validated with any credibility that was actually a map. And this is a list of all of the known supervolcanoes in the world. Okay. So it took me a little while to put this together, but I use it quite frequently as I look at volcanoes because I'm curious if a swarm or a group of volcanoes sets off, are they near one of these supervolcanoes? And you hear things in the news about, one of these goes off every 1,000 years, but I don't think people realize how many there are around the world. So if one goes off every 1,000 years, well, I think that it's a good idea to take a look. Because what if two go off, in 1,000 years, or at once? If you look into what supervolcanoes are and what that means, a supervolcano is classified as a VEI 7 or 8, and that's kind of like an earthquake. You hear about magnitudes. VEI is a volcanic eruption index, and some of the really big ones in the world are down around 3 and 4. Certainly make the news, 5 and so forth, and they get exponentially larger as the numbers go up. What I've got on this map is VEI 7s in green and VEI 8s in red. Okay, so the 8s are obviously more rare. There's not as many of them, but we really need to keep an eye on them. Now, when we look at concentrations of these, obviously it looks, Japan is an area. The last known real supervolcano eruption was over here with Toba, the red one there. Okay, and so Indonesia is a hot spot, lots of earthquakes and activity happening in there. And then notice this region over here. How many people knew there were this many supervolcanoes in the United States? Actually, this one appears a tiny bit into Canada, but you get the idea. So there's a lot. And Europe is relatively free. You got Italy, and I'm going to talk about this one, Campi Flegrei, and so forth in just a moment. But what I want to note is if we move in, there are two that we really want to keep in mind. Now, this one is pretty dormant. I haven't seen any activity in Colorado like to worry about at this point. But up here is Yellowstone, the red dot. If I zoom on in, and you notice there are two other. They tend to kind of swarm. Where you see one supervolcano, there could be more than one. But those are VEI 7s. And then over here is one that never makes the news, but is probably most important right now to keep an eye on, and this is the Long Valley Caldera. Okay, and you can see them highlighted over here as I mouse over them. So, so why are these of any concern? And I'm going to touch on these two first. And I may wind up wrapping up the video. We'll see how long this goes. This may be a 2 or 3 part series. But let's take a look at latest earthquake activity. And this is USGS, so as long as we're in the US, I'll use this. And this is 7 days, all magnitudes. All right, so the US does a lot more reporting than Canada does, and that's why we're seeing this. This is USGS, so Alaska and the US. There's a lot of tiny volcanoes happening all around us. Okay, and so you really have to learn what all these tiny volcanic eruptions mean. Before you really step into this, or it'll kind of freak you out, to be honest. So don't do that, okay? But up here, if we go in, I'm going to try and explain as much as I can. Right here, in the corner of Wyoming, and a little bit in Idaho, this is Yellowstone National Park, and the Yellowstone Caldera is right down here. Doesn't look like a lot of activity, does it? Well, truth is, since June, recorded on this site have been over 3,000 volcanic eruptions, and most of them are very small, as you see over here, 1.9s, 2s, usually in the 1s, that kind of thing, and they started disappearing. So I've seen them actually disappear. They show up and then they get downgraded and then they disappear. So this is 7 days, all magnitudes, and I think that they've pretty much, best I can tell, and this is just me being observer, they're turning off the seismographs. And yet we keep getting news stories about scientists being concerned. So I really believe this swarm is continuing. I don't know what, that doesn't necessarily mean it's going to erupt. I'll let you figure out the science and listen to the scientists, but that is a sign that something's moving, either magma or steam. Okay, it could be water. There's, you see there's a lot of lakes and rivers over here, and this is what gives, Old Faithful its steam source and so forth. Well, there's water lower than Old Faithful, and if those reservoirs load up and the magma chamber starts heating, just heating from pressure, then it can force a very violent eruption of steam. Maybe we're headed to that, and that would be bad, but that would just affect kind of regionally in sort of a bad way. If an actual supervolcano goes off, it affects world climate. We would see clouds globally. The sun would be dimmed. I mean, this is what happened to the dinosaurs, okay? Now, there's a swarm down here that also makes the news. This is on the southern end of Yellowstone. Nobody really knows what's going on here, but there's a lot of speculation. I can't explain that one, but that is a very unusual quake swarm, and it's been going on now for over a month. Anyway, moving on, let's stick to supervolcanoes. What do we normally see with these supervolcanoes? Well, this is hard to move around when you got it. Let's do this. 30 days significant. Now it'll move around a little smoother. But there's always volcanoes over here. And if I go to here, you see an area here. There's right in this area here. This is the Long Valley Caldera. Let's go to 7 days, all magnitudes. Look at that. There's the caldera right there. So this is what Yellowstone used to look like. In fact, it was a bit more dense than this. But this is telling us that magma or steam or is either moving or an increased pressure. Okay, and there's a difference there that I'll explain in a moment. But this guy right here is getting very little press. And this caldera, this is a supervolcano, VEI 8, extremely devastating potential, is showing remarkable activity. And the interesting thing is that if you look over here, you'll see, look, at 0 depth, that's the depth, kilometers. So if you come down here, you will see some, look, like -2. That means that The rocks are cracking, and earthquakes, tiny little earthquakes, fracturing earthquakes are happening within the mountains in this area, okay, above ground. That's what negative means, because these are usually depth. So it would be a positive number would be deeper and deeper into the crust in the mantle, right? So 2.2 kilometers above grade in the mountains, we've got cracking and so forth. So this one, it's a little unnerving, and I don't know a lot about supervolcanoes other than my observational kind of studies, but something's definitely going on here. Will it be steam? Will it be magma? Well, there's another option, and this is why I wanted to kind of touch on this a bit. Let me get back to something a little more reasonable. Okay. Up here is what's called the Juan de Fuca tectonic plate. A lot of people don't even know this is here. It's a teeny tiny one, right? Well, the thing is, most of it is underground, and it's pushing up under the North American plate, and this is that boundary. So this is when you hear about the Cascadia subduction zone. That's what this is. And it builds up, builds up, builds up, loads of pressure, and then boom, and it moves. And if we get a 9.0 is what they're actually predicting, in the geological, quote, near future, I don't know, that could be 100 years, it could be tomorrow. Then we get a tidal wave that shows up in like 15 seconds and floods everything you see in that particular region, okay? So Northern California all the way up through Washington, and even, Vancouver Island up here in Canada. So that's a big deal. And what do we see as some of the signs here? Well, Yellowstone is definitely a region where we're seeing pressure build up that could be from this plate sliding into the United States or getting ready to move. Also, another example, and this is not a supervolcano, but it's a good example. If we look up here and we go to, again, all magnitudes, and we see a little swarm here, right? We come in, and again, if I zoom in like that, all right, you notice that there should be some little negative numbers. This, my friends, is Mount Rainier, okay, which is a volcano. Now, this, again, I have to qualify it. I've done a fair amount of research on this one, and this is showing an increased pressure on the magma chamber. However, it is believed that that is just pressure. It's not like going to erupt, and nobody's making that prediction. But that pressure is an indicator, if I back out again, that there is a real serious growing pressure on that Cascadia subduction zone. This is so hard to do when you've got all magnitudes turned on. Okay, so that's something to watch. That particular fault line right there is of high intensity. It's affecting Yellowstone, and so I'm saying this because if you see something about Yellowstone, remember that it could be just pressure on the magma chamber caused by this Juan de Fuca tectonic plate, which actually is much bigger and underneath North America, and mashing and causing pressure on the Yellowstone magma chamber. Okay, so those are the kinds of things we have to watch for. Other things I can show you with regard to interest is if I go to currently, let's get out of there for a second. Currently active volcanoes. All right, you can see there's quite a lot. Last count, the red ones are actually, really erupting. The orange ones are small lava pools and subtle eruptions, and the yellow ones are just unrest. Okay, unrest doesn't mean a lot, except that it means that it could erupt in the near future, but they're usually smaller volcanoes and so forth. Now, if we see unrest on a supervolcano, that's a different story, right? So you notice Yellowstone, nothing in the United States is flagged whatsoever, despite what I just showed you and the pressure on the magma chambers. So that either means that they're downplaying the potential risk, or that the real risk has to do with the San Andreas Fault and the Cascadia subduction zone building up pressure right now. I don't have an opinion on that. It could go either way. These things are, I think a lot of people would have trouble making a prediction, but those are the two things that could be happening there. But if you look over here, see that yellow one right here? All right, China/North Korea border. China, what? Well, you may have heard about this in the news. You know what's happening right here just south of that super volcano, by the way? That is a super volcano. North Korea is doing all of their underground nuclear tests right near a super volcano. So the last one was a hydrogen bomb underground right there, which created a man-made 6.1 magnitude earthquake. Okay, and that doesn't sound smart to me. But anyway, because of that, this volcano has been given a status of unrest. There's been earthquakes in it and some cause for strain. Also down here in southern Japan, neither of these that are active are supervolcanoes, but there's a supervolcano right square between them. Okay, so things like that we watch for, right? The other one that I watch that is actually flagged. If we zoom in, don't leave our European friends out. A couple volcano names you might have heard of. This one is less known, Stromboli volcano. Stromboli is actually the name of a kind of volcanic eruption where magma balls are being thrown through the air and so forth. And that's the volcano that process is named for. It's erupting now. And then down here you might have heard of Mount Etna, currently erupting. You haven't heard that in the news, have you? So, not really huge, but this is an example of what's going on. These are significant volcanoes is my point. And what's this one? What? Campiflagre, okay? Super volcano. All scientists on hands, all hands on deck right here. There were earthquakes a couple months ago and a lot of nervous people shuffling around and a lot of changes happening around this volcano. So of all of the supervolcanoes, this is the one I'm actually watching pretty close just to see what the scientists are saying, because there's a lot of them in there. And of course this would affect Europe in a profound way if it did erupt, not to mention the rest of the world. Okay, so that's supervolcanoes. I'll go back to my little chart and we'll back up so you can once again get an idea of what it takes to stay on top of these things. Okay, they are always here, and this is just something that we have to deal with. Okay, I'm going to go ahead, and this is going to make it a little long, but I'm going to touch on hydrothermic vents just to check the box and move on with it. What is a hydrothermic vent? I've got a couple pictures here. In fact, let me see if I can do this as fast as possible. All right, so here, just to save some time, this is what a hydrothermal vent is. It's on the bottom of the ocean, usually around fault lines, but not always at all. And this is where it pulls water in. The hot magma is close to the surface of the Earth, underwater, and it pulls that salt water in through just sort of capillary action all around. It gets close to that magma, heats up really hot. You see 1200 Celsius. So like 2000 Fahrenheit, and it boils up and shoots up into the ocean. All right, so 2000 degree salt water pushing up into the ocean at the bottom of the ocean, and it goes up. This would be just over 400 degrees Fahrenheit here, and then it continues to cool as it goes up. But this goes all the way to the surface. So when you see hot spots on the surface of the ocean, where it's like hotter than average, then that's a clear indicator that you've got hydrothermal vents happening on the bottom of the ocean. The other thing that we can do is this sends a bunch of sediment, just like a volcanic eruption, into the water. And these particles, look, CO2. Huh, interesting. Okay, so the particles come and fall out, and they create these sediment areas. And what this does, it usually looks kind of porous and rocky, and so you can spot these if they're big enough and there's enough of them in a single area. Usually there's multiple all around over miles and miles. And if they all erupt at once, you get a real plume. You can even see in the satellite data, which I could show you. We'll see if I have time. And this heats the water. I mean, don't you think? And in fact, in Antarctica, they've spotted these all around Antarctica, and the life is thriving all around it because it's warm, it's CO2 rich. It's just an environment that's very conducive to unique life forms. Little crabs and certain fish and so forth, right? So anyway, moving on, I thought I would share a quick picture. Okay, this is taking a temperature reading at the top of a hydrothermal vent. The minerals that come up out of here build up and create these really cool looking towers in a lot of cases. This would be a black smoker There are also white smokers, that's different minerals in the water, and so forth. So this is what it looks like, and they certainly have a lot of data about hydrothermal vents. So now, if I come here, and this is Wikipedia about hydrothermal vents. I encourage you to check all this out, but I want to scroll down, and there's a great map. Here's the known hydrothermal vents. See all the red dots? I wonder, you think that would heat the water? So they're going crazy, and they cannot track them. There's too many, and they're too deep. So it's very difficult to determine, are there more, are there less? Are they erupting more violently with hotter water or less? It would be such a huge job to track this. By the way, notice the North Pole is littered with these. I've mentioned this in a couple of my previous videos. We are going to see some North Pole ice melting this year, and I believe these are very active up here right now. So keep your eyes open. Also, I think this area over here, although it's not really shown, is waking up as well. So there's hydrothermal vents warming the Baltic Sea and north of Alaska. Okay, so anyway, the important thing that I want to point out is there's something else that made the news. And I'm doing this just to give you some examples of warming water, okay? This just came out. I don't see a date on this. But anyway, it was like yesterday. Hole the size of Maine opens in Antarctica ice. Okay, and I think there's a better picture there of it. Where is that? Well, I can show you. Let's go back to my old friend. All right, I'm going to turn it on to water. I'm doing this really fast, so bear with me. Water, and I'm going to look at, it doesn't really matter what I look at, I guess, but temperature anomalies. Okay, so I want to come down here and look at Antarctica. That hole that they're talking about, you can actually see right here. It's not quite this big. There's water on the surface as well, but you can see that it's right off the coast, okay? And I want to note where it is, okay? So you see this hump, and then it's right out here, okay? So now, if I go to Google Maps, and we go down, oops, I'm in satellite view. My computer's moving very slow. I got a lot open that's constantly updating right now, so bear with me. And we look, let's zoom in, right off this hump. See that? Would you say, just as an observer, that that looks like what we might call a sediment field, right? Which I just talked about with hydrothermal activity. Let's zoom in some more. Now they got it kind of foggy, but look at these little holes and little volcanic little mountains in here. Okay, so when you hear, and I'm telling you, I've been spotting these. I can show you another one that's even clearer, but I don't know if I have time right now. But that's a hydrothermal field, and it's right under this big, mysterious, I mean, they're talking, that's not right, here. They're talking about this
Smithsonian Channel present.
Unknown, pardon the ad. Scientists are baffled. You know, they have no idea what's causing this giant hole in Antarctica. Hot water coming up from the Earth. See, they can't pin it on CO2, and it's not even on the edge. This is like way up in the ice sheet. That's hot water coming up from underneath. It's so simple. Basic math, right? And yet, as far as everything you can read, if you look this up, it'll be, you know, researchers are totally baffled and don't understand what's causing this. So one quick note, now I'm going to wrap up. Look at the yellow here. Okay, what we're looking at now is a map of SSTA, sea surface temperature anomalies. So what they've done is they've taken average, there's buoys all out here in our oceans. Maybe I'll point that out at some point and show you how that works. But they're floating around collecting temperature data deep under the surface, at the surface. This is surface temperatures. Okay, you see these warm areas? Now this is under ice, and that's why this one's not showing up as yellow, but these are way south. Okay, we've got hydrothermal activity happening there. We've got hydrothermal activity happening all the way around here. Okay, and then just to have a little fun, you know, I mentioned I think we're going to see the Arctic ice sheet melting a bit this year, and boom. I've tracked these in previous videos, and if you go back and look, you'd see that there was a lot less warmth last year. Look at this warmth in Alaska. Okay, so there is look, if you zoom in, this is another interesting thing. You saw what was happening with the ice sheet and that hole in Antarctica. Look at this. We actually have temperature differentials here. And that's C, so let's go to Fahrenheit. There are times when these, and maybe if I got just the right spot, you'd see they are like 1 degree difference. There's another one. Half a degree, which is actually a lot. You're looking at ice here. This is still an ice sheet. Everywhere you don't see the little squigglies moving and these little guys. So there's pools forming on the surface that are warmer, which indicates there's actually that fault line comes right up through here and then back down and over to Japan. So we've got hydrothermal activity happening, folks. That's my point. It's heating the earth, is heating the water. The water is heating the air. Global warming. You know, am I a global warming denier? No. Do I deny that human contribution to CO2 is actually heating the entire planet? Yes, of course. That's silly. Okay? So that's where I stand on it. Now, another point I always make at the end of these videos, and I'm going to wrap up, is, let's go back to our volcanoes. I'm not saying we don't need to be good stewards. I'm not an irresponsible person. Compost, recycle, all that kind of stuff. We want to be good stewards, and there's some other things that are very real too, like this giant island of plastic trash floating around the oceans. So I'm not one of these people that says we can just continue on. We need to be responsible and look at things like solar and wind and things that make sense. But I do think it's important to have the context and understand. If we're going to understand what is causing climate change, we have to admit first that it is not CO2. Then we open the discussion and start to solve this problem. Most pressing question is, why is it happening? What causes this, even if it's a normal trend? Why? Okay, so simple questions, but we have to get to where we can ask them. And that's the point of this video. So everybody, have a great day. This is much longer than my normal video, but I hope this was helpful and meaningful to you. If you have any questions, let me know. If I've gotten something wrong or you have some criticisms or comments to make, always welcome. Just please be kind of polite when you do it, and I'm happy to have a discussion. Thanks so much.